Welcome to exercises solution of mathematics for class 9. It's new syllabus latest edition 2020-21 for KPK textbook board Peshawar. In this tutorial we will solve the questions of exercise 1.5, which is about the matrices, chapter number 1, matrices. Before going into the solution of the different question of exercise 1.5, let's discuss some background. So this exercise is about the multiplicative inverse of a matrix, that how you will determine the multiplicative inverse of a matrix. Again, before going into the detailed discussion of the multiplicative inverse, let's discuss some other basics, which is first one is the determinant of a square matrix. For example, if we have a square matrix A, B, C and D, suppose that is matrix A, okay, then with every square matrix a unique real number is associated, which is called the determinant of the matrix, and that is represented by A with these two parallel lines, or sometimes that is represented by det of A, determinant of A. And the determinant of A is equal to the product of the primary diagonal element, mean AD, minus the product of the secondary diagonal element, AD minus BC. That is the determinant of a square matrix. Okay, then we have two types of the matrices. One is called the singular matrix and the second one is called the non-singular matrix. So a square matrix A will be called a singular matrix if its determinant is 0, and a square matrix will be called a non-singular matrix if its determinant is not equal to 0. We will determine its determinant, and if it is equal to 0, it will be a singular matrix, and if it is not equal to 0, it will be non-singular matrix. Another one, we have adjoint of a matrix. So adjoint of a square matrix is denoted by ADJ of A. For example, if we have a square matrix 2 by 2 square matrix A is equal to A, B, C, D, then its adjoint will be represented here, denoted by ADJ of A, and that will be equal to, we will have to interchange the primary diagonal element, mean D will be changed with A, and just change the sign of the secondary diagonal element, minus B and minus C, mean the sign of these two elements will be changed and these two elements will be interchanged with each other. Then we have the multiplicative inverse of a matrix. Okay, for example, if we have a matrix A which is non-singular, remember A will be non-singular matrix, mean its determinant will be not equal to 0. Okay, and for example, if we have another matrix B, so if the product of A and B is equal to the identity matrix, mean if we have a matrix A and suppose we have another matrix B, and for example, if the product of AB or if the product of BA is equal to identity matrix, okay, then B will be called the multiplicative inverse of A. Okay, suppose if we have a matrix A and if we multiplied another matrix B with A, and for example we get the identity matrix, then B will be called the multiplicative inverse of matrix A, and the multiplicative inverse of a matrix is represented by A to the power minus 1. We will solve the question in exercise. Then we have the adjoint method to calculate the inverse of a non-singular matrix. Okay, suppose if we have a matrix A, then its inverse, multiplicative inverse, will be equal to 1 over determinant of that matrix multiplied by adjoint of that matrix. Okay, we have to find out the determinant of the matrix and then the adjoint of the matrix. So 1 over A determinant multiplied by adjoint of A, that will be the multiplicative inverse of the given matrix. Okay, then we have a property, which is, suppose if we have a matrix A and if it is multiplied with its multiplicative inverse, it will give us the identity matrix. okay, or if the inverse of a matrix A is multiplied with that matrix, it will give us the identity matrix. Okay, and then we have another formula. For example, if we have two matrices A and B, so the inverse of their product will be equal to the product of the inverses of individual matrices, but remember that will be in reverse order. Mean if we have two matrices A and B, take the product of AB, then find out the inverse of AB. So the inverse of AB will be equal to the product of the inverse of B matrix and A matrix. Okay, different questions will be solved in exercise. So let's see. Question number 1, find the determinant of the following matrices. Okay, so as we know that for this one, determinant of A will be equal to the product of the primary element, so 5 multiplied by 1, that will be 5, minus the product of the secondary diagonal elements, 6 multiplied by minus 4, so that will be minus 24. So it will be equal to minus minus, it will plus 5 and 24, it will be 29. So that is the determinant. Okay, determinant of matrix B, that will be represented like this one, and it will be equal to the product of the main diagonal element, 4 multiplied by 13, it will be 52, and minus 2 multiplied by 5, so it will be minus 10, and it will be equal to 52 minus minus 10, so it will be 62. Okay, the determinant of the matrix C, that will be equal to the product of the main diagonal element, so again 11 multiplied by 5, it will be 55, minus the product of the secondary diagonal element, 7 multiplied by minus 6, so it is minus 42. Now 55 minus minus 42, that will be 97. So it is the determinant of matrix C. Similarly, the determinant of matrix D, that will be equal to 5 multiplied by minus 9, so it will be minus 45, and minus 6 multiplied by minus 8, so it will be minus 48. Now minus 45 minus minus 48, so it will become plus 48, minus 45 plus 48, it will give us 3. Okay, similarly the determinant of matrix E, that will be equal to the product of the main diagonal elements, so 2p multiplied by minus s, it will be minus 2p and s, and minus multiplied the secondary diagonal element, minus 3q multiplied by r, so it will be minus 3qr, and here we have minus, so it will plus 3q and r, so its determinant is minus 2ps plus 3qr. Okay, now come here, it is 3 by 3 matrix. So for example, if it is a diagonal matrix, mean if the rest of the element is 0, then its determinant will be find out by this method, that suppose this is 1, so cancel the first row and first column. Okay, and take this element, for example that is 1, it will be multiplied with the determinant of this matrix, so it is 1 minus 0. Okay, so 1 multiplied by 1 minus 0, it will give us what? 1. Okay, similarly for this H matrix, that will be equal to the determinant of the H matrix. Cancel the first row and first column, but here we have element A multiplied by B multiplied by C, so it will be BC minus 0 multiplied by 0, it will become 0, so the determinant will be equal to A, B and C. Okay, so remember this procedure will be followed if you have the diagonal element. Now we have to find out the diagonal of this G element. So for the determinant of this matrix, so see there are different method to find out the determinant of the 3 by 3 matrix. but here we will use the simplest method. Okay, so write the matrix. Now write the first column again. Okay, write the first column here again, 1 3 minus 2. Write the second column here. Okay, 2 2 minus 3. Now draw the diagonals. One diagonal will be 1 2 4, another will be 2 3 minus 2, another will be 2 3 minus 3. Find out the product. 1 multiplied by 2 multiplied by 4, so that is 8. Okay, 2 multiplied by 3, that is 6, multiplied by minus 2, so it will be minus 12. Mean 8 the product of these diagonal. 2 multiplied by 3 minus 3, so 2 multiplied by 3 6 minus 3, that will be minus 18. Okay, minus, now draw another 3 diagonal like this one. Okay, 1 2 and 3, so minus 2 multiplied by 2 multiplied by 2, it will give you minus 8. Then minus 3 multiplied by 3 minus 9 multiplied by 1, so it will be minus 9. 4 multiplied by 3, that is 12, multiplied by 2, that is 24. Mean 8 the product of the diagonal this wise and minus the sum of the product of the diagonals of this wise. So from here, if you simplify it, you will get 29. So it will be the determinant of matrix G. Okay. Question number 2, which of the following matrices are singular and which are non-singular? So just you have to find out the determinant, and if the determinant is equal to 0, it will be singular, and if it is not 0, it will be non-singular. Okay, so 5 multiplied by 1, that is 5, minus 3 multiplied by 2, that is 6, is equal to minus 1. So it is a non-singular matrix. Okay, now the determinant of B, that is equal to 3 4s are 12, minus 6 multiplied by minus 2, it will be plus 12, is equal to 0. So this is a singular matrix. Okay, similarly 3 multiplied by B, so 3A multiplied by B. Okay, that is the determinant of matrix C. 3AB minus 2B multiplied by 2A, so it will be minus 2AB. Now you can write it that it will be 4AB, so minus minus, that will be plus, so 3AB plus 4AB, it will be 7AB. Mean the determinant is not 0, so it is a non-singular matrix. Come here, the determinant of matrix D is equal to minus 3 multiplied by minus 4, it is 12, minus 6 multiplied by 2, that will be 12, is equal to 0. So again it is singular. Okay. Question number 3, find the adjoint of the matrices. So for matrix A, it is represented like this one. Adjoint of A is equal to, interchange the main diagonal element, mean interchange 4 with 1, and just change the sign of the other elements. Okay, so that is the adjoint of A. Similarly for the next one, adjoint of B, that will be equal to, interchange these two elements with each other, so it will become 3 and minus 3, and change the sign of these elements. So it is minus 1, here it will become plus 1, it is plus 2, it will become minus 2. So that is the adjoint of B. Okay, similarly the adjoint of C will be equal to, just interchange these two elements, it will become 1 and 2, and change the sign of these elements, so it will become 4 and minus 3. So this is the adjoint of C. Similarly the adjoint of D, interchange these two elements, so it will minus 4 and minus 3, and change the sign of these elements, so it will be minus 6 and minus 2. So this is the adjoint of matrix D. Okay, find the multiplicative inverse of the following matrices if they exist. Now remember, if a matrix is a singular matrix, then there will be no inverse for that matrix. Mean the inverse will be only existed if and only if the matrix is non-singular matrix. Okay, if the matrix is non-singular matrix, then the inverse will exist. So that is the point, that if it exists. So see, we know that per matrix A, the inverse of A will be equal to 1 over its determinant, okay, multiplied by adjoint of that matrix, adjoint of A. So what will be the determinant? So 4 multiplied by 1, that will be 4, minus 1 multiplied by 3, so that is 3, is equal to 1. Okay, so the determinant is 1. And what will be the adjoint? So just change these two elements, it will become 1 and 4, and change the sign of these elements. It will become -1 and -3, -1 and -3. So again 1 divided by 1, that is 1. So if it is multiplied with the matrix, so again you will get that same matrix, 1 minus 1 minus 3 and 4. So this is the inverse of matrix A. Okay, so the rest of them is same. Let's solve another one. For example, the inverse of matrix D, that will be equal to 1 divided by determinant of D, okay, multiplied by adjoint of D. Okay, so just find out the determinant. So 0 multiplied by 4, that is 0, minus 3 multiplied by 2, that is -6, so it is equal to 6. Okay, so this is the determinant of matrix D. So 1 divided by 6 multiplied by adjoint, interchange these two elements, so 4 with 0, and change the sign of the other two elements, 3 and 2. Now just simplify it. 1 over 6 multiplied by 4, so you will get 2 by 3. Okay, 1 over 6 multiplied by 3, so you will get 1 by 2. Okay, 1 over 6 multiplied by 2, you will get 1 by 3. 0 multiplied by 1 over 6, you will get 0. So this is the multiplicative inverse of matrix D. Okay, similarly it will be determined per B, C and A. Just find out its determinant and multiply it with the adjoint of the same matrix. Okay, now if A is equal to this one, B is equal to this one, find out AB, then BA, and then A inverse and B inverse. So let's first find out AB. Okay, mean A product B. So both are 2 by 2 matrices. The number of column of A is equal to the number of row of B, so AB product is possible. Now first row with first column, so 2 multiplied by 1, it will become 2, plus 0 multiplied by -1, it will 0. Now first row with second column, so 2 multiplied by -1, so it will become -2. 0 multiplied by 3, so plus 0. Okay, now second row with first column, so -3 multiplied by 1, it will be -3. 1 multiplied by -1, so it will be -1. -3 multiplied by -1, so it will 3. 1 multiplied by 3, so it will become 3. Now that is the product of AB, which is 2, -2, -4 and 6. Okay, that is AB. Similarly, find out BA. Now we have to find out what? BA. Okay, so for BA we have to multiply the first row with first column. So 1 multiplied by 2, that will be 2. -1 multiplied by -3, so it will be +3. Now first row with second column, so 1 multiplied by 0, it will be 0. -1 multiplied by 1, it will be -1. Now second row with first column, -1 multiplied by 2, that is -2. 3 multiplied by -3, so it will be -9. Now second row with second column, -1 multiplied by 0, so that is 0. 3 multiplied by 1, so that is 3. So this is the product of BA. So 2, 3, that is 5, -1, -11 and 3, so that is BA. Okay, Now we have to find out the A inverse. Okay, so A inverse will be equal to 1 over determinant of A. So determinant of A is 2 multiplied by 1, that is 2 minus 0 multiplied by minus 3, 0. So that is the determinant multiplied by the adjoint. So 1, 2, 0, either it will be minus or plus, and 3. So that is the A inverse is equal to, just simplify it. So it will be 1 by 2, it will be 0, it will be 3 by 2, and it will be 1. Okay, so this is A inverse. Similarly, find out the B inverse. So B inverse will be equal to 1 over determinant of B. So determinant of B is 1 3s are 3 minus 1 multiplied by minus 1, it is 1. So its determinant is also 2. So 1 over 2 multiplied by its adjoint. So interchange these two and change the sign of these two. So it will become the adjoint of matrix B. Now just simplify it. So it will be 3 by 2. Okay, here we will have 1 by 2, 1 by 2, and 1 by 2. So that is the inverse of matrix B. So we have finded out the product of AB, product of BA, inverse of A, and inverse of B. Now we have to find out the inverse of AB. Okay, so inverse of AB will be equal to the determinant of this matrix. So 1 divided by 2 6 are 12 minus 2 or minus 4 multiplied, so it will be plus 8. So the determinant of AB matrix is 4. Okay, 1 over 4, and its adjoint will be 6, 2, 2 and 4. Just change these two elements and change the sign of these two elements. It will adjoint, and it will be equal to what? 6 multiplied by 1 by 4, so it will be 3 by 2. 2 multiplied by 1 by 4, it will be 1 by 2, and 4 multiplied by 1 by 4, it will be 1. 2 multiplied by 1 by 4, it will be 1 over 2. So this is the inverse of AB. Okay, now we have to find out B inverse multiplied by A inverse, mean B inverse multiplied by A inverse. So that will be equal to, again see, we have B inverse is 2 by 2 matrix, A inverse is 2 by 2 matrix. So multiply B with A. Okay, so the first row with first column. So 3 by 2 multiplied by 1 by 2, so it will be 3 by 4 plus 1 by 2 multiplied by 0, it will be equal to 0. Sorry, 1 by 2 multiplied by 3 by 2, it will be 3 by 4. Now first row with second column. So 3 by 2 multiplied by 0, it is 0, plus 1 by 2 multiplied by 1, that is 1 by 2. Now the second row with first column. So 1 by 2 multiplied by 1 by 2, so it is 1 by 4, sorry, 1 by 4, plus 1 by 2 multiplied by 3 by 2, so it is 3 by 4. Now second row with second column, 1 by 2 multiplied by 0, it will be 0, plus 1 by 2 multiplied by 1, it will be 1 over 2. Now just simplify it. So 3 by 4 plus 3 by 4, it will give you 6 by 4, or it will give you 3 by 2. 0 plus 1 over 2, so it will be 1 over 2. 1 by 4 plus 3 by 4, it will be equal to 4 by 4, or 1, and this will be 1 over 2. Okay, so this is matrix 2. Now you can see that 1 is equal to matrix 2. Okay, so it is true that AB whole inverse is equal to B inverse multiplied by A inverse. Okay, similarly, if you find out the inverse of BA, inverse of this matrix, it will be equal to the product of A with B. Okay. Question number 6. If A is this one, B is this one, then show that AB whole inverse is equal to B inverse and A inverse. So again, first find out the matrix AB, product of AB. So product of AB will be equal to first row with first column. So 0 multiplied by 2, that is 0, plus minus 1 multiplied by 1, so that will be minus 1. Now first row with second column, so 0 multiplied by 3, that is 0, plus minus 1 multiplied by 0, that is 0. Similarly, second row with first column, so 2 multiplied by 2, that is 4, 1 multiplied by 1, that is 1, 2 multiplied by 3, that is 6, plus 1 multiplied by 0, that will be 0. Okay, so it will be equal to minus 1, 0, 5 and 6. This is AB, that is 6. Now find out AB whole inverse, mean find out its whole inverse. So it will be equal to 1 over determinant of AB. So what will be its determinant? Minus 1 multiplied by 6. It is minus 6 minus 5 multiplied by 0. So that is 0 is equal to minus 6. So the determinant of AB is minus 6 multiplied by its adjoint. So interchange these two and change the sign of these two. So that will be the adjoint. Now it will be equal to 1 over minus 6 multiplied by 6, it will be minus 1, this will be 0, this will be 5 divided by 6, this will be minus 1 divided by 6. So this is AB whole inverse. Okay, for example, this is matrix 1. Now we have to find out the B inverse. It is equal to 1 over determinant of B. So 2 multiplied by 0, it is 0, minus 3 multiplied by 1, 3 is equal to minus 3. So that is the determinant of matrix B. Now the adjoint of B will be 0, 2, minus 3 and minus 1. Okay, so it will be equal to 0, 1, 1 by 3 and 2 by 3. Okay, so this is the inverse of B. Similarly, the inverse of A is equal to 1 over determinant of A. So determinant of A will be 0 minus minus 1 multiplied by 2. So that is minus 2 is equal to 2. Determinant of A is 2 and its adjoint will be 1, 0, 1 and minus 2. Okay, so the inverse of A is equal to 1 by 2. Okay, 1 by 2 and minus 1 and 0. Okay, this is what? This is A inverse. Now find out the product of B inverse multiplied by A inverse. Okay, so it is equal to first row with first column, so 0 multiplied by 1 over 2, that is 0, plus 1 multiplied by minus 1, so it is minus 1. Okay, now first row with second column, so 0 multiplied by 1 over 2, that is 0, plus 1 multiplied by 0, so that is 0. Okay, now second row with first column, so 1 over 2 multiplied by 1 over 3 multiplied by 1 over 2, so it is 1 over 6. Okay, plus 2 by 3 multiplied by minus 1, so it will be, we can say that minus 2 by 3, it will be minus 2 by 3. Okay, similarly now the second row with second column, so 1 over 3 multiplied by 1 over 2, 1 over 3 multiplied by 1 over 2, so it will be 1 over 6. Okay, and 2 by 3 multiplied by 0, so it will be 0. Now this is equal to what? Minus 1, 0, and if you simplify it, it will take the LCM 6, so it will give you 5 by 6, okay, and this one is minus 1 by 6, okay. So it gives us the for example, this is matrix 2. So again, now the matrix 1 is equal to matrix 2. It means that AB whole inverse is equal to B inverse multiplied by A inverse, okay. Here sorry, here we have minus 1, so it will be plus 1, and here also we have plus 1 over 6, okay. So the two matrices are equal. Now the two matrices are equal, mean AB whole inverse is equal to B inverse and A inverse, and similar case will be followed for the inverse of BA, that will be equal to the product of A inverse multiplied by B inverse, as we have also find it out the A inverse and B inverse, okay. So A inverse multiplied by B inverse will be equal to the inverse of BA. Here we have find it out AB, but this is BA. So first find out the product of BA, take it inverse, and it will be equal to the product of the inverse of A with B, okay. So this was all about exercise 1.5. Thank you for watching. Subscribe the channel for more videos, and comment if you have any question or suggestion, and share it with your friend. Thank you.